until April 1st. So it is one of those days where in the middle of the week. So, hey, Melanie, good to see you. Keegan, Caleb, good to see you guys. Thanks for getting in there, Anella. Hey, Cheyenne, good to see you. Rainey. So, I've got something at the end of the hour here. If you're interested, we'll do True Truths and a Lie or a Kahoot. So after we'd gone over the review. So if you want to work on your assignments, you can, but you can also do Two Truths and a Lie with us or the Kahoot on spring break. Hey, good morning. GM to you. How are you guys doing? How are you doing, Rainey? Excited for spring break, I hope. I am. I got the grandkids coming. All right. Well, that's okay. It's all right. It's only 9:06. What'd they do in advisory that it ran over? I hope it was fun. Good morning, Isabella. And who else did it came in? Madison, good morning. And Namara, good to see you. Savannah, good to see you too. Oh, quiz on standard testing. Oh, okay. Okay. Standard testing. Okay. So I've not done that. I probably should. All right. So I've got 3 people in here. We're going to get started here. All right. So if you can jump in anytime. Okay. This is a review on work and power. Let me turn my. All right. So what is a force? Okay. Remember, it's a push or pull, right? Push or pull. Right? Push or pull. Got 3 people in there. Next question. Ben, go ahead. All right. All right. What unit do we use to measure work? Remember, that is a joule. A joule. Good morning, Noara. All right. A joule. All right. 3 people. All right. You got anybody else get in there? You can, for sure. It's a good review. Next question. All right, next question. All right. Work is force times, what is it? It's distance. Force times distance. All right, force times distance, for sure. Hey, thanks, Namara, for getting in there. Right? Takes a while for people to get when they get in there. Great job, guys. Next question. All right, where are we here? Come on. All right. What kind of energy is a moving skateboard, kinetic or potential? Remember, kinetic is energy of movement. Kinetic is energy of movement. Oh, thank you, Namara. Next question. Anybody else want to get in? You certainly have time to do that. There's the link. All right. I got one more person in there. All right. What kind of energy is rock? Oh, guys, you guys answered it without me here. That is potential energy. Potential energies. Energy of holding on the quiz. Potential. Kinetic is movement. Potential is stored energy. So you put a rock on the edge of the cliff, it is potential. All right. How do you work a problem like this? If you have 20 newtons to move a block 10 meters, right? All right. If you so 20 times 10. 20 times 10 is the joules. 10 times 20, 20 times 10 should be 200. 200. 200. So chart view, 200. Can you get that one, Namara? 200 should be the answer there. 20 times 10. All right. Sometimes it gets stuck. Can't answer it if sometimes. Which of these situations do you aren't doing work, holding heavy book stacks and while standing, carrying heavy books stacks, dropping a stack of books on the table, picking up a pile of books on the floor. It's picking up a pile of books on the floor because all these other ones is not in the same direction. Picking a pile of books up on the floor. Yep, picking up a pile of books. Good job, guys. Next question. Where are you? Next question. Next question. All right. The blank is the SI unit for energy. It's the joule. Again, the joule is the SI unit for energy. Good job. Everybody got in there. Next question. All right. When work is done, there is always transfer of energy. Transfer of energy when work is done. Next question. There you go. Doesn't always want to give me that. Ability to do work is energy. Energy is the ability to do work. Energy is the ability to do work. Score is there. Everybody's got. Come on. Let's see the question. Which of the following is the no work? Climbing stairs, lifting a book, pushing a shopping cart? None of the above.Ose are all work situations. Climbing stairs, you're going up. Lifting a book, you're pulling it the same way. Pushing a cart, yeah, those are all none of those. All right. Come on, next question. Next question. All right, if you exert a force of 10 newtons and lift the box 2 meters, how much work did you do? 10 times 2, what is it? 10 times 2. 10 times 2. All right, 20 newtons on that one. Come on. Hold me up. What is energy? Ability to do work, right? Ability to work. Work is energy. Energy is ability to do work. All right, and we have the last here. So that was what we got. Okay, excellent. Third place, Anella Maddox. Good job, guys. Just faster responses here. Okay, good job. Thanks so much. Okay, so today what we're talking about, we're doing review of for power, and we're going to talk about power a little bit. I think there's only one question on power. I'll give you more of power on Friday. I'll give more of an assignment, not an assignment, but some of a video on power. So I can define work, power, and energy. Okay. Describe the relationship between each of. I can calculate work and power. I can identify the different forms of energy. No live class on Friday. Yep, you're right. There is no live class on Friday. It is open. Help sessions will on Thursday. Take your unit test. Spring break is next week. So, and I should have put down that it's asynchronous on Friday. All right. So, stay testing. I will be out probably 2 weeks. I might only be out 1 week. I have only 31 people to test. Archibald only has 31 people to test. Okay, so power, work, right, is defined as a product, which means multiplication of the applied force and the distance. and it has to go in the same direction. Hey, George, good to see you. Hey, Brianna, good to see you too. Hey, Randall, good to see you as well. Roman, excellent. Got you in here. I'm glad. And Jadon, good to see you as well. I didn't say good morning to you. All right, so it's a scalar quantity and it's a joule. Okay, so those are some things. I have these slide decks in the notes for you guys to help you out. All right, so force that no work, forces that no work. So in here, okay, so if I look at this one, get a pen here. All right, my headphones off here. If the work object does not move, no work, right? If the object, so you holding, you might be exerting some energy, then they can, this is considered potential energy here, but work is not being done. So no work here, right? No work here, no work here, right? You are exerting energy, and there's no work here because you're holding up, but you're moving. So it has to be in the same direction. So no work is done. Okay, lifting. So even though you help your parents moving, still no work is done. Okay, so example 1. Okay, so let's see if we can get this one in a typed poll response. Okay, so what is the force? What is the force? Okay, question mark, and I'll have you type your response. Remember, it's going to be in a J in there. Start a poll. All right, so if we do this one, all right, so let me get this here. So you have 40 newtons, right? That's your force times your 3 meters gives you something in joules. What is that? All right, excellent. It's a times here, ladies and gentlemen. The times, 40 times 3. All right. Okay, thanks, Jay. Thanks, Rainey. Thanks, Maddox. Thanks, Abriana. Anella. Good job, guys. There we go. So this is 120 joules. Okay. So like I said, we're going to be talking about, 120 joules. Okay, so power is the rate at which an object's done its work. So this one is taking work and then putting a time to it. Force times distance divided by time, right? So power is on an object over a distance per a specific time. So work divided by time. So all we're going to do is do the time. So in this particular question, let's start a poll here. A or B. Let's do this one for you guys. This is the last poll question, actually. I'm just going to go over there. What has more power? So I'll show it to you as far as the more power. P-O-W, looking with one finger here. Okay, so A or B on this particular one. All right, so which lifting a box, they both do work, but now we're going to divide by 10 seconds or so the same amount of work and 5 seconds. Okay, so let me try this out for you guys. So this one, so the work done here, so the work is equal to 500, right? 100 times 5. This is the work. 100 times 5. So the same, but this we're going to divide by 10, and this we're going to divide by 5. And we're going to call that watts. So what do you think? A or B? 500 divided by 10 or 500 divided by 5? What do we got? Oh, we got 7 people. Thanks. Out of 21, we got a big group here. You know, by 6th hour, I don't hardly get anybody doing this. Hi, Skylar. Thanks for getting in there. Roman, thank you. And George, thank you. So I got some people in A and some people are B. So I've got, okay, so far I've got 3 people say that is, and then 6 people says that is. Okay, so 500 divided by 5 is 100 watts. Okay, 500 divided by 10 is 50 watts. So it makes sense that if you can lift something faster, you have more power, you're stronger. Maybe if you think about somebody being stronger versus weaker, I can do that job in 10 seconds, or I can do that job in 5 seconds. So the less time it takes you to do, the more power you have. So that's pretty straightforward, I think. All right, so energy is as potential or ability to do work. Forms of energy, remember we talked about gravitational, potential energy, kinetic energy, energy of motion, heat energy. Who else did we get in here today that I did not say hello to? All right, we got Alyssa. I can't think of Janaya. I haven't say hi to Janaya. So energy is the ability to work, can be transferred to another object, can be transformed from one type to another, and is measured in heat and in joules. And we'll be talking about transfer of energy in the weeks coming up. So kinetic energy due to motion, energy due to position, or stored energy is called potential. So here are the forms of energy. Potential, chemical energy, nuclear energy, stored mechanical energy, and gravitational energy. Kinetic energy or energy of movement is light energy or radiant energy, thermal energy, motion, sound, or electrical. Now, we can here, so here's some chemical energy. So breaking the bonds of something here, we have a combustion response. You hit a match on that, and then you've got breaking the bonds. That's potential before, kinetic afterwards. Nuclear is potential energy. You know, you hit it with a neutron, and then you can get to break down. Stored energy in that spring from the Roadrunner. I used to love Roadrunner shows. I always wish they'd had more of them. And then gravitational energy, another Roadrunner. Look down, look down. This is a obvious physics problem that doesn't happen in real life, where you can stand in midair and not have gravitational energy impact you until you realize it. All right, forms of energy, thermal energy here. You can tell the thermal energy, the molecules, when we heat them up, will move much faster than in cold. Sound waves, we'll be talking more about sound waves. Kinetic energy of motion and electrical energy. Right, so here are the forms. Okay, so you'll have some questions on the test about kinetic and potential energy if you haven't done them already. Here are the notes on that. Right, electrical energy can be classified as potential or kinetic. It's classified as potential before it's released, and when the form as electrons or electricity. Once it's converted from its potential state, energy becomes kinetic energy. And then there's the types of electromagnetic radiation. And again, we'll get into that in more in the future here. Okay, so we are just about that. We are done. So let's have a vote here. If you want to, let's start with this one here first. How many people are interested in doing a, all right, let me give a vote here. Let's publish the poll here. How many people would be interested in doing, start a poll here, 2 truths and a lie, because we're not going to meet with each other for another week. and a lie, okay, or do their class, do homework. All right, homework. So if you'd rather do homework, let's see how many people would rather do this, A or B, homework, or two truths and a lie. So again, I'm only doing two truths and a lie if I get people to do it, right? So you have a choice. A lot of people are wanting to do their homework, but I got 4 people that say they'll do two truths and a lie. All right, so that seems like a 50-50 chance here. If you want to do the homework, you can. Okay, so if we'll probably have less people vote, so let's do this. We'll do the two truths and a lie because I got a 50-50 chance here. All right, escape. Okay, so two truths and a lie. All right, so here we go. We're going to start a lesson here and instructor base. So we're going to do this on Pear Deck. Pear Deck. And we'll vote. So this is two truths and a lie. Give you the link. All right, let me publish the poll here and clear the poll out. Clear. There you go. If you're interested in doing two truths and a lie, here is how you do that. You get into this Pear Deck and you can get into that to do your two truths and a lie. I got one person so far. All right, start the class. So happy Wednesday, as I said. Okay, there you go. Two truths and a lie. Get started on that, and then we will vote. So you can do anything you want. You could talk about if you're going on vacation or not, where you're going. If you are going, you can talk about your pets. But remember, make it so that it's a little bit tough, because if you tell them, like, I like math, people will think that's the lie, and you may like math, and that you won't be able to convince them. Or don't say I like pizza, and if you like pizza, you don't like pizza, people will think that's, you're not telling the truth. So you got to find something. I got 3 cats, so my lie would be, I have 2 cats, I only have 1, things like that. You can't. Oh, you know what? You're right. Thank you much. I got to make a prompt. I forgot to make a prompt out of that. Thank you so much for telling me that. All right, here we go. Drawing. Come on. There we go. Sorry about that. I forgot all about that. There you go. Now you can type. All right, I'm going to put this on pause, ladies and gentlemen.